Hey guys, welcome to my YouTube channel. I thought of doing a video on this problem, and this is also one of my first videos on this channel because I found it extremely hard to understand the solution, so I thought of creating one myself. So I made it in a way that's a bit different from how others have showcased the solution. So this is assuming that you already are familiar with the binary search algorithm. So without any waste of time, I'll just get started. So what is a median? In math, the median is the middle value in a data set that has been arranged in a numerical order. So here we are given the data in the form of an array. So once that array is sorted in ascending order or descending order, so in this problem we'll be dealing with how the data is arranged in ascending order. So once it's arranged that way, we take the middle value. So we also need to consider the total number of elements the array has. For in this case, our first array here has 5 elements. That's odd, so the middle value can be calculated as 5 by 2 is equal to 2.5. we'll round it up to 3. So the third element here is 5, and in our second array we have 1 2 3 4 5 6 elements. So dividing it by 3, 2 will get 3, but in that case we need to average the 2 elements that come at the middle. That's 3, the third element, and 3 plus 1, the fourth element. So 4 plus 8 by 2 is 12 by 2, that's 6. So that's how we calculate median. So how does it apply to our problem? So in this case we are given 2 arrays. We can pretty much go ahead and combine these 2 arrays, sort them, and find it based on the middle index like this. But the problem is that it will take n of time. That means you need to go through each element at least once. So you need to I think it just says O(m plus n) because if m is the length of the first array and if n is the length of the second array, O(m plus n), which basically means like you need to go through all the elements, assuming if n here is the total length of the combined array. But we are supposed to solve it without taking as much time. I think it's n log n that we need to use at most. So here we definitely need to use a binary search algorithm in order to do it as fast as possible. So here I thought of explaining it by reverse engineering from the solution which I saw on the internet. So let's assume that we know the median first and then try to work our way back and find a solution. So assuming that these 2 are our given arrays and we have combined and we found the median line. Let's change the color here. So here 1 2 3 4 5 6 7 8 9, there are 9 elements. So 9 by 2 is 4.5, rounding out to the highest integer, closest integer, that's 5th. So the 5 is our median. So what I want you to imagine is that let's rearrange the numbers without mixing up the numbers. So what I thought of doing was we'll enlarge this line, median line, and rearrange in such a way that no number crosses to the other side or vice versa. So here in the original combined array we have 1 2 3 4. That 1 2 3 4 is still on the left side, and the rest of the elements are still on the right side. I just wrote it in two rows so that it's much easier to understand. The only difference is that this arrangement gives us the array1 in the first row and the array2 in the second row. Sorry for the bad drawings. So in this case, this is the ideal case, and this line here is just one step away from helping us find the median. I'll explain why. Our assumption. Earlier I said that on the left side of this line we have half the elements, and on the right side we have the other half. Here it is, there's an additional one more element, but that's fine, it's because it's odd. So if it were even, there'll be 4 elements here and another 4 here instead of 5. So because the median is always the middle element, the left side of the red bar, our median line, should have equal number of elements if the total length is even, like I mentioned before, or the right side is 1 more than the number of elements on the left in case the total number of elements were odd. But in this case, yes, it's odd, so we have 1 additional element. And let's define some terms that we will be using in our code. So the left one will be the first element to the left side on array1, and right one will be the first element to the right side of the red bar on our array1. And similarly, left 2 would be the left element on our array2, and the right element to the red bar on our array2. And we also define the indices I and j. I is the place where the red bar crosses our array1, and j is the place where the red bar crosses our array2. So since this is the ideal case and we already know where the median is, and all we did was to rearrange the numbers in 2 rows such that it makes array1 and array2, on closer inspection we can see that the left one is less than right 2 here, like this, and the left 2 is less than the right 1. That means we have perfectly placed our red bar so that it's just 1 step away from solving the problem. So like I said before, the left side should have the half the elements of the total combined array, and the right side should have the remaining. So that gives us a constraint that I plus j. I is the index where red bar crosses the array1, and j is the index where the red bar crosses the array2. I plus j should always be equal to the half of the total elements. We need to keep this in mind. And so j is calculated every time we assume a new value of I. So this constraint we cannot break by the definition of median, and it also means that we can calculate j for every value of I we assume. Yeah, so far we explained everything knowing where the median actually was, but our goal is to find the I and j such that the condition left less than right 2 and left 2 less than right 1 is met. So that is the ideal placement of our red bar. So this is another example which is different from the ideal placement which is shown before. This is a previous slide. So I will go ahead and show you how it's done. So this is where our binary search comes in, to find the I value fast so that it doesn't take n time. So we use the binary search to find I, and with that we can calculate j and check if we can match the criteria. Remember, this is the criteria we are looking for to find the median. If not, if this condition is not met, we move I and j such that the number of elements remains same on the left and right side of our median bar. Let's define left and right. This is for the binary search part. So I took left as 0 and right as the total length of the smallest array, smallest size array. So if you know the binary search, you know what calculation is going on here. So the middle value that we are going to find I is calculated as the left plus right divided by 2. We'll take the smallest closest integer to this value, that is 0 plus 5 divided by 2 is 2.5, but we'll round it off to 2 here. It's 2, and the total length 11. The total length is 11 for our combined array. So j is calculated as half minus I. So half is 5 minus I is 2, which is 3. So using this I and j value 2 and 3, here is a redrawn. Here's how we place our red bar. If you observe carefully, this is 0, this is 1, this is 2. The red bar crosses the array 1 at index 2, and the red bar crosses the array 2 at index 3. And now we check the condition here. If the left one is less than right 2, that is correct because 2 is less than 8, but the problem is 7 is not less than 3. So that creates a problem. So what we need to do here is that we need to decrement j, because this value should be lowered. The left 2 should always be less than right 1. So the lower value is to the left of 7. So we need to decrement j and we need to increment I. Remember, j and I are having a restriction because I plus j should always be half the total number of elements. So I will shift j and I in such a way that we find a new I, and with that we find a new j, and we'll redraw the line in order to find the new median bar. Ta-da! So I'll just go back to the previous slide and to the next slide once more, just to show how the arrays moved. The reason why the array moved so quickly is because we are doing binary search. So we will again use the binary search on our array 1 in order to find a new I value. Remember, our previous I value was 2. So we make it I plus 1 for our next iteration, that is 2 plus 1 is 3. You can look at this array here, and our right value remains 5, and we compute the middle value and we get it as 4. If I is 4, j will be equal to 1 because I plus j should be equal to half the element, which is 5. 11 divided by 2 is 5. And now we move our I and j to the new location. The red bar remains fixed, and we shift the I and j, and we see if the left one, the criteria of left and right stands or not. So here it is, left 1 is less than or equal to right 2, because 4 is less than 6, that's correct. And left 2 is less than right 1, left 2 is 0 is less than 5, which is correct. That means we have ideally placed our median bar here. I'll just move to the previous slide once more to see how the array 1 and array 2 has moved. So this is our array 1, this is array 2. Check how it has moved. So we found our median line. So at the beginning of the video I mentioned that finding this line will help us find the median. So our next step is to do some minor calculation. That's it. So since binary search is so fast, we found the median bar in just 2 steps. It's so quick that I couldn't do more simulation. And the last step is to find a median based on total length. So since the total length here was odd, here it was 11, we can find the minimum of right 1 and right 2. The minimum of right 1 and right 2 here is minimum of 5 and 6, which is 5, which is correct. And if it were a different example, and if it were to be odd, we need to find the average of the minimum of right 1 and right 2 and the maximum of left 1 and left 2, because if you make this comparison, you'll understand why. And for edge cases where the I and j indexes that we use to track the position of our median bar, if it is at the edge here, for example, there's no value here, so we don't want our code to crash. In that case, we can assume positive or negative infinity for doing this check, for this check here for finding the placement of our median bar. So that's it, guys. I hope my explanation helped you understand this problem better. Please comment, please make a comment so I can understand how to improve my explanation. Thank you very much and have a nice day.